Okay, review Unit 6. So there's a couple of different things that are happening in here. Make sure that you understand what a tree diagram is. A tree diagram is going to break things apart. So which diagram best represents all the outcomes of rolling a number cube? Okay, so what are the outcomes on a number cube? They're 1 through 6, and it says that right there. One time. So we're just rolling a number cube one time. So A only goes 1 through 4. So that can't be it. And then B is saying it's going to 1 and then giving you an option of 4. We don't want to do that. All options have the same equal power. So 1 and 2 here, going to 3 and 5, that's not going to work. Clearly, D is your best answer choice. Okay, because it gives you all the options on a tree diagram. Number 2, Manny and Kyle are playing a game. They toss a fair 6-sided number cube. Okay, numbered 1 through 6, and they spin a spinner which is divided into 3 equal regions, 1 colored red, green, and 1 colored blue, which lists all the possible outcomes of spinning a spinner and tossing the number cube. I, myself, on something like this, would list the possible outcomes myself and then find an answer that matches. So, like, I would start with the colors because there's a smaller amount of them. So I would say red 1, red 2, red 3, red 4, red 5, and red 6. Green 1, green 2, green 3, green 4, green 5, and green 6. And then blue 1, blue 2, blue 3, blue 4, blue 5, and blue 6. Okay? So that's all of my option choices. So notice on A, does it list all, does it even combine them? No. Okay. On B, it says red, green, blue, 1. Can you get all of those on the spinner at the same time? No, you're only going to be able to get 1 on the spinner. So that's not going to be an option. This is red 1, red 2, green 3. That's not even getting with every color because you can hit green and every number, right? Because they're on 2 separate things. So D is your option. It should have all the ones we just listed below. Right there. Okay. Number 3. 4 of Miss Hopkins' classes are going on a field trip. Each class has an equal number of boys and girls. Miss Lard is creating groups. It should be Miss Hopkins. Sorry. I edited one, but I didn't edit the second one. My fault. Okay. It's creating groups that have 1 student from each class by randomly selecting students' names from a list. Which simulation could Miss Hopkins use to create the groups on the field trip? Okay. So flip 3 coins where head represents boys and tails represents girls. Okay. Which simulation? 4 of Miss Hopkins' classes. Each class is an equal number of boys and girls. 1 student from each class by randomly selecting students' names from a list. Select a marble 4 times, returning each marble after a selection. The bag has an equal number of purple marbles, green marbles, red, blue, where each color represents a class. Roll 4 number cubes where each cube is 1 class. The number of the even numbers on the number cube represent a girl and the odd numbers represent a boy. Roll 4 number cubes where each cube is 1 class. The numbers 1, 2 on the number cube represent a boy. 3, 4, 5. Okay, so this is not even right here, right? Why? Because it didn't, like 1 and 2 were boys and 3, 4, 5, 6 are girls. So there was a higher chance of getting a girl, right? Okay. So flip 3 coins where head represents boys and tails. So what's wrong with that one? Or is something wrong with it?
3 coins and there's 4 classes.
4 classes. Okay. Okay. So B. Is that going to help us decide boy or girl?
No.
No. Okay. It could help us decide the classes. It's creating groups that have 1 student from each class by randomly selecting. So it really doesn't matter. They're equal, right?
Yes.
But how would you pick the person from each class?
You wouldn't.
This is a hard kind of question.
Yeah, after taking it out, you put it back in, so it doesn't.
Then they would all have an even chance.
Yeah.
C.
And
I think
okay,
it's C.
I think it's C because B's
It's
just telling
C.
you, oh,
C.
Because they got an even chance of selecting.
So you're going to pick a girl from class 2. Is that what you're saying? Roll 4 number cubes where each cube is 1 class. The even numbers. Okay, so that could work. I see where B could go too, though. Okay, I don't really love both of those, either one of those, so we need
I
to
thought they
look.
were both kind of weird. I kind of picked C earlier when I was looking at it.
Okay, if Paul rolls a fair six-sided number cube, 1 through 6, 36 times, about how many times should Paul? Okay, here's where, when it says about how many times or something, it's getting a bigger, we're going to do a proportion. But first we have to decide what is happening. So we're looking at how many times should Paul expect to roll a number less than 3. What are the odds of rolling a number less than 3? 2 and 1, so 2 out of 6, which reduces to 1/3. So a third of the time, he's rolling a 1 or a 2, right? So out of 36, well, 1/3 is 1 time out of 3. So how many out of 36 is where we're going with that? So we would scale up times 12, which would give us 12 times, which is answer choice D. Okay, number 5. Sydney wants to participate in an after-school program. She has a choice of 2 art classes, 3 dance, 2 gymnastics classes, or 3 sports classes. She cannot decide, so she writes the name of each class on a slip of paper and draws 1 slip out of the bag. What is the probability she does not draw a dance class? So we want everything but dance. Well, there's 2 art, 2 gymnastics, and 3 sports. So there's 7 of those, and there's 3 dance. So 7 out of 10. So what we want out of our total outcome. So total and what we want, which is answer choice D. Okay. Number 6. Julia spun a spinner 35 times. The table below shows the number of times the arrow of the spinner landed on each of the 6 colored sections. Julia wants to predict how many times the spinner will land on yellow if she spins the spinner 50 times. Okay, so right here we need to find the probability that we have. So we have 14 out of 10, 17,
35.
so 27, 35. So 14 out of 35 times right now, okay? So if she spins it 50 times, ooh, that's ugly. Okay, 50 times. How many times would she get? Okay, so we're predicting. Okay, so let's predict. Let's think about this. If this is getting bigger, then it has to be more than 14, right? Okay, so Julia predicted that the spinner would land on there 22 times since it landed on yellow about 3 less than half the time. Well, that's true. It also landed on about 50 less than half the time. So if we said 50, could I solve for that?
No, right here.
Yeah, what would I get? 35x, 50 times 14. 50 times 14 is 700 equals 35x. Divide by 35, divide by 35. X is going to equal, so it's going to say about 20 times, right? So x is going to equal about 20 times. Okay, I could see the logic there. Julia predicted the spinner would land on yellow 20 times since the spinner landed on yellow. If you reduce 14/35, what does it go to?
It goes to
2/5. If you divide by 7, you get 2/5. Since the spinner landed on yellow 2/5 or 35 times, it would land on yellow 2/5 of 50. That's a good prediction. I think I like that one the most. Let's look at C. Julia predicted the spinner would land on yellow 35 times. Well, we already decided it needed to be more than 14, but not close to 35, right? Okay. And then this one is 33 times, so we're out there. So our answer is B. Okay. Number 7. Samuel rolls a fair six-sided number cube, numbered 1 through 6, and records the results. Which statement about the experiment is true? He is more likely to roll an even number than an odd number. Okay, what's wrong with that statement?
because there's equal, even, and odd numbers.
Yes, our options are 1, 2, 3, 4, 5, 6. An even number is 3, 6, and an odd number is 3, 6. So that is not true. We're looking for the true statement, right? He is more likely to roll a number greater than 4 than an odd number. What's greater than 4? 2 out of 6, and an odd number is 3 out of 6. So is this one going to be more than this one? Nope. He is more likely to roll a prime. Okay, what's my prime? It's 2, 3, and 5. So 3 out of 6. Then a composite. What's my composite? 4 and 6. What are we doing with 1 there? What are we doing with 1? 8th grade teacher.
I'd say no one.
Okay. He is more, okay, so I'm going to say 3 out of 6 to 2 out of 6. He is more likely to roll a number greater than 5 than an even number. That's not true either, so it's got to be this one.
I knew it.
Okay, number 8. Hold on, we got a couple more minutes.
I thought I'd create an algebra for
Number 8. Focus. Number 8. Paige is conducting an experiment. Okay, this is the one y'all were having trouble with. Using 2 spinners. She spins each spinner, recording the results, then spins again. She repeats the experiment 10 times for each spinner. Her results are shown below. Based on the results, do a blue spinner from 1 and an orange from 2. So the blue spinner is 2 out of 10. The orange spinner is 3 out of 10. So first things first, you have to multiply those. 2 out of 10, 3 out of 10. Okay? So I would get 3/50. How many out of 300? Well, if it's 3 out of 50, how many out of 300? I would scale up there. Times 6. Times 6. And I would get 18. That's that one we worked earlier. Okay, so I'm going to stop it there. I'll do the next video with the next thing. So there and we'll finish that tomorrow.